All right, hi everybody. These are the solutions to your little survey today. So about the normal distribution. So we're just going to take a few minutes here. Okay, so this is about we know that the machine normally fills with volumes of liquid that are normally distributed with a mean of 16 ounces, standard deviation of 0.01 ounces. The first question here is, what does the standard deviation mean? So the standard deviation, we interpret standard deviation as the average distance from the mean. So this means that that the volumes produced by this machine are 0.01 ounces away from the mean of 16 ounces on average. Or we would say the average distance to the mean, or the average distance of the volumes to the mean of 16 ounces is 0.01 ounces. Either one of those interpretations is fine. Okay, but that's the average distance, is how you interpret standard deviation. So number two, bottle is randomly selected and they find that the bottle contains 15.95 ounces of liquid. Find and interpret the Z-score. Okay, one quick little note here that I wanted to touch on. A Z-score is also called a standardized score, because when you do a Z-score is your value, like let's say X minus the mean divided by standard deviation. When you subtract the mean, the new resulting data set has a mean of 0. That's back to our shifting data, transformations of data little lesson. And then if you divide by the standard deviation, it divides the standard deviation by itself, so it becomes 1. So this has a mean of 0. It's called standardized because it has a mean of 0 and a standard deviation of 1. So anytime you see a standardized score, Z-score, that means the same thing. That was actually one of the free parts of your free response question the other day. So this is reviewing that a little bit too. So what is the Z-score? My value for this bottle was 15.95. The mean was 16. The standard deviation was 0.01. When you subtract that, you get negative 0.05 divided by 0.01. That is negative 5. So what that means is that this bottle, this volume of 15.95 ounces is 5 standard deviations below the mean of 16 ounces. Z-score, always the number of standard deviations away. Okay, so that's number 2. Number 3, two things could go wrong in production. Either the machine underfills, which would be bad because then they are marketing a 16-ounce bottle and it's not actually doesn't have 16 ounces on average, which would not be good. They could get sued. Or the machine is overfilling. In other words, they're losing out on money because they're putting too much product into their bottles. So there's 2 ways to shut the process down. So what they decided is the company will stop production if they randomly select one bottle and the bottle has more than 16.03 ounces of liquid. How often should they expect to stop production for this reason? So this question right here is all about finding a proportion on the normal distribution. So here's your normal distribution for this. So remember, a good normal distribution's got at least a labeled mean and standard deviation over here. But even better is if you tick mark out a few standard deviations so you can understand what's going on. It's got shading. So what's that? 16.01, 16.02, and then this one would be 16.03. So it says it's going to stop production. It's going to stop production if this bottle is more than 16.03 ounces. So in this area on our curve over here. Okay, so there we go. We've established our curve. We know it's normal. We know the standard deviation, we know the mean, we have shading, we showed me direction. So at this point then, you just got to figure out this, this proportion. Two ways to do it. Number one, you can use the 68, 95, 99, 7 rule, the empirical rule. You know that this is the third standard deviation. You know that within 3 standard deviations, that is 99.7 or 0.997, almost 100% of your data. In this case, 100% of the volumes, 99.7% of them. So what we need to really figure out is just this little piece over here. So if we take 100% or 1 minus 0.997, this is going to give us 0.003. And because we only care about, that would give us both tails here, but because we only care about one of those tails, we divide it by 2, and that's 0.0015. So we would expect, how often? We would say as a percentage, this is multiplied by 100. So this would be 0.15% of the time we expect a bottle over 16.03 ounces. Okay, super rare. So if it happens, that's probably not a good sign because it shouldn't happen, right? It's not expected to happen. Okay. Second way to do this is using your calculator. So if I pull that open for a second here. So to use your calculator, you go to second, distribution, and normal CDF to get the probability or the proportion. Your lower bound was 16.03. Upper bound is infinity, so we just use a really big number. The mean is 16. Standard deviation is 0.01 ounces. There you go, about 0.013. So it's small amount. And again, we talked about this a little bit. The reason your calculator is slightly different in this number is because the rule that we have, the empirical rule, is a rough approximation. It's good. It's a good approximation, but it's a rough approximation. So either one of those are acceptable. And the final question was, what is the 75th percentile of this distribution? In other words, what is the third quartile? That's another way I could have asked that question. So for that one right there, what we're talking about is we want to know where is 75%, at what number for our volume is 75% of our data less than that. So we need a spot here. We talked about this is, we know that this is in here, 1 standard deviation from the mean is 68%. That would leave 16% here and 16% here on our curve. So technically 16.01, if you add 68 and 16, that's technically, this is the 84th percentile. So we know that the 75th percentile has to be somewhere between 16 and 16.01. What we're trying to find is this number right here. And we want this area that I'm about to shade in black to be 0.75. We can use your calculator function, inverse normal, to do that. So you go to second, distribution, inverse normal to get the percentile. You put in the area that you want, that's the left. So less than that, 16, and then 0.01. And there we go. You see it's just a little bit over 16 ounces, but it's between 16 and 16.01. So the 75th percentile or the third quartile, Q3, would be 16.0067 ounces. So we would expect 75% of these bottles to have a volume at or below 16.067 ounces.